anti-meridian. That is on the other side. Okay, like I told you, if it is 000, it is 000 of the new day. If it is 2400, it is 2400 of the previous day. So all the above. Okay. Local mean time always changes by a day when crossing. Rajesh, what is the answer for number 3?
Boy, sir. Bravo.
Again?
Bravo.
Yeah.
180 degrees.
What did you say?
Ball. Sorry, bravo.
You don't use Alpha Bravo. What is this? Apple ball and all is very in school, yeah?
Yeah, sorry, sir.
Okay, no. Just pulling your leg. Okay. So it is 180 east west. Zone time is used. Zone time is used by who, Nina? We discussed this. It is used by
Charlie, by ships at sea.
Ships at sea. That is why the concept of zone time came about, because of the difficulties experienced by ships. Okay. A ship at longitude 83 observes sunrise at zone time at 500 zone time. Okay. And zone date is 15th. What is UTC? There. How do you get this? Yeah, number 5. How do you get UTC? Go on there. All right. Okay. Joling. How do you get UTC when you have zone time and zone date? Zone time and zone number? Come, Joling, quickly. Joling, you heard me?
Yes, sir. Yes.
Yeah, please answer here. What is the answer? How do you get UTC with zone time and zone number?
The almanac?
No. Ashraf.
You subtract or add the zone time depending on whether it's
No,
at
no,
east
there's no
or west.
depending on. Yes, number 5.
So
A ship at 83 east. Okay. 5 o'clock, 0500 zone time. How do you get UTC here?
5 minus 6 hours zone time.
How much is 83 east?
Roughly 5 hours
Roughly,
40
yeah.
minutes here.
So 5 hours 40 minutes. Zone number is what?
6 plus 6.
6. So
Take the 5 out of the 6, subtract, then you get alpha.
2300.
UTC
Yeah?
at 14.
Yeah, okay. So guys, please remember UTC is zone time plus zone number. All right. Now zone number could be in minus, could be in plus, depending on whether we are discussing easterly longitude or westerly longitude. When we are talking about westerly longitude, it is plus the zone number. When we are talking about easterly longitude, it's minus. Right? So zone time plus zone number will give you the UTC. Okay. On a midsummer day, in the southern hemisphere, the sun will be over. Hakimi.
Charlie, sir. 23
Number 6.
Charlie.
That is 23.5 degrees south. Yeah. Okay. Because the sun is overhead the Tropic of what?
Capricorn.
Capricorn. Very good. Okay. And Hakimi, on midsummer day, on midwinter day in the northern hemisphere, where will the sun be?
Will at the same place, 23.5 south.
Absolutely. Right. Good. Okay. All right. Giovi, you've done question 2, right? So question 2, A. How did you question 2A?
You find it the UTC first,
Okay.
which is
How much you get UTC?
you minus 6 hours and 53 minutes from 10:45.
No, tell me. If it is longitude west, is the number 2 problem. Longitude is west. Okay. So UTC will be, UTC is best. So you don't have to minus, you add it. No.
Yeah.
Okay. I hope you all have done it, huh? Otherwise, I'll just skip over this, go off, and you guys will be quite lost. Okay, Xiaomi, because it is west, you have to add. So how much do you add? How much is 830? Longitude? How much is the longitude for 8 degrees 30 minutes? It is 34 minutes. Arc time, you see it says when LMT is 008 at 00830 is 2300. What is it at 10830? Now you told me that you will change it to UTC. So how much does this come UTC? Is 2300 at 00830. How much is UTC? Ziovi, how much do you add? What is the time difference? Ziovi, you've done this, no? You
So
did
is
it, no?
question number 2, right?
Yeah, question 2, part 2.
Not
Ziovi, I will
question 1.
No,
I think
we finished question
Javi thought question number 1, so that's why.
We finished question 1, Ziovi. We are at question 2.
Okay.
Okay, we did in question 1, we did from 1 to 7. Okay, question 2. So I said we'll skip 1. Question 2, Ziovi, how did you do part A? You said you first converted to UTC?
Yeah, you plus
Okay.
34 minutes.
34 minutes. So how much is the time at in UTC? It is
34.
34. Okay. Now we have to find, you have to change it back to LMT for 10830. So 10830 is how much?
7 hours and 14 minutes.
Okay. So what do you do to that?
Minus.
Okay. So how much does that come to?
1620.
1620. On what day?
On the same day.
On the same day. Okay. 160. Yeah. Okay. Abdul, do B of number 2. How do you do B of number 2?
So 108 degree 30 minutes is. So the changes on longitude, I got it, is 7 hours and 48 minutes.
7 hours and
48 minutes.
40.
So the
7
LMT.
hours and?
No.
7 hours and?
No. The answer is 6 hours 48 minutes. 10 May.
Is it 6 hours 48 minutes?
10 of May. Yes, the answer is 6 hours 48 minutes. 06.
Yeah, but
40.
what I'm saying is, how did you do it, Abdul?
Okay, so the difference of
you first changed to UTC?
Actually, I didn't change to UTC. I simply calculate the difference of longitude. So the difference of longitude I get is
How much is, what is the difference of longitude?
117 degree 15 minutes equal to 7 hours and 48 minutes.
Okay, so you did it directly.
Yeah, directly.
Abdul, remember, I have told you all as a matter of habit. change to UTC and back again. You will not make a mistake, because when you get slightly more complicated questions, you will run into difficulty. So as a matter of habit, even this, right, what you should have done is change it to UTC and back again. Understood, Abdul? This is not incorrect. Getting the change of longitude and dividing it by 15 and getting the time is not wrong. But it is better to stick to standard procedure, change it to UTC and back again. You will never make a mistake. Is that clear, Abdul?
Yes, sir.
Yeah, okay. So what you've done is not incorrect, but standard procedure, change every time to UTC and back. All right. Who's this? Lynn. Do number 3. Do number 3A. And how did you do it?
The UTC is provided
Yes.
13 hours on 1st of April.
Yes.
And then we calculate the change of longitude, which is 7 degrees and 15 minutes.
For A.
So, and then I get 29 minutes, and then I add it.
Why do you add it?
Because it's at the east. So longitude is UTC list. So we are changing from UTC to the local mean time. So we need to add.
Thank you. Good.
So
okay, Rajesh. Sorry. Yeah, Lynn.
So
Yes, sir.
No. Who was I talking to just now?
Lin, sir.
Yeah. No. Who did 3A? Lynn, no?
Yeah.
Yeah, okay. All right. Lynn, you got it right. That's the way to do it. Rajesh, do B. 3B.
We minus, they gave us
Yeah.
the UTC already. So,
Yeah.
and then we got our, it's just 7 hours and 11 minutes. So we got it on, we got the answer at 0549.
Okay, so you minus.
I minus.
You minused it?
Yeah, I minus it.
Why? Because?
West.
Wonderful. Thank you. All right.
Welcome.
Okay, thanks. Ashraf, 3C.
I add the arc time onto the UTC, sir.
How much did arc time come to? 3C?
Arc time is 11 hours, 14 minutes.
Okay. So when you added it, how much did you get? You
So
added
when we
it to
added
13 hours.
Yep. So it becomes 0014 on the next day.
Okay, thank you. Good. Okay. What we'll do now is we'll do number 7. Hakimi, do number 7.
Okay.
An aircraft is to fly from Wellington, New Zealand, that is 17454 east, to Samoa, which is 17145 west. Okay. So the estimate flying time is 6 hours and 15 minutes. So give the standard time and date of departure from Wellington. If ETA is 2350. That means now you have to work backwards.
Yes.
Yeah. Okay. So what is it that you did, Hakimi?
So firstly, I find the arc time for Samoa to change to UTC. So
how much did you get that?
The arc time is 11 hours, 27 minutes. So I plus with the LMT. So I got the UTC 11:17 on.
11:17 is UTC. Okay.
Yes, UTC.
Then to that, what did you do to that?
Then I minus the flight time.
Right. So how much did you get?
0502 on 9 September.
Right. What did you do next?
And then I refer to the almanac to get the standard time on Wellington.
For Wellington.
Yes.
And how much is that?
Plus 12.
12. Good. And so you got 1702.
Yes.
Very nice. All right. Thank you. Ziovi, you didn't do 3, no?
No, I didn't.
Okay. Do number 1, Ziovi. Determine the LMT in Wellington. Okay, the UTC is 70730. Okay, how do you do it? How do you get local
Find the
time?
arc time.
Yeah, how much is that?
11 hours and 39 minutes.
11 hours and 29 minutes. Okay, 11 hours and how much?
39.
39 minutes. Okay. Then what did you do to that? Did you add or subtract it?
Subtract.
Huh?
Yeah, you plus.
You added it because longitude east, UTC least. Yeah?
Yeah.
So UTC will be less than Wellington. So you added it and you got how much?
1909.
Okay, thank you. Good. Zioling. Do number 2. Local mean
Yes,
time,
sir.
Boston is 1200 hours.
Yeah.
What
Plus
is the
the
UTC?
art time.
Okay, how much does the arc time come to?
4 hours 45 minutes.
Okay, and you added it?
Yes.
Okay, and what did you get?
16:45.
Okay, good. All right. Okay. Oh, Ikwan, you're online.
Yes, sir.
Good. Ikwan, can you do number 3? And no, number 4. Question 3, part 4.
Question 3, part 4.
Yeah. You did the whole lot, no, Ikwan?
Yes, sir.
You
Yes, sir.
completed the.
I completed
Okay,
it, sir.
good. All right. Do part 4. And question 3. Aircraft leaves Brisbane.
I got the answer is 12:45 standard time zone in Philippines, sir. In Manila.
Okay. Now let's see, go step by step to see, for the others to revise also. So an aircraft leaves Brisbane at 2200 hours on 4th and lands in Manila 6 hours and 45 minutes later. So what is the LMT and standard time of landing? Yeah. So
Yes.
what did you do? How did you go about it?
22,000 plus 6 hours and 45 minutes, sir.
No. What did you do?
I'm using the formula UTC plus arc time in order to find the LMT, sir.
Okay. So to 0300. No. This is number 4, no? Yeah. So arc time was how much?
Up time, I got 8 hours and 4 minutes, sir.
8 hours and 4 minutes. Number 4. Yeah. Okay. So you first wrote down 2200, no?
Yes,
Yeah,
sir.
2200. On what date is this?
4th May.
4th, 2200. And then you found the arc time. And you said how much was the arc time?
8 hours and 4 minutes.
8 hours and 4 minutes. This is for which longitude?
Manila.
Manila.
1085 East.
Okay. Why don't we go about it step by step? Now this fellow leaves at 2200. Yeah, on the 4th of May, right? And
Yes.
then he flies for 6 hours and 45 minutes.
Yes.
Yeah. So if he leaves at 2200 and he flies for 6 hours and 45 minutes, what time UTC will he arrive?
0445.
0445. And now you do that. Now you find out what is the LMT for 445?
8 hours and 4 minutes, sir.
And how did you get that?
By using the longitude of Manila.
Of Manila. So 12058, when you divide it by 15, You get how much?
8 hours and 4 minutes.
8 hours and 4 minutes. So you got LMT how much total?
Um,
Local time is more or less than UTC. It is longitude east, UTC least. So you have to add it. Correct?
yes, sir.
So when you added it, you got what? 1249.
Yes, 12:59.
Yeah. And now after that, you have to get the
The
standard
standard
time.
time
Yeah.
using almanac, sir.
Yeah. So how much is it UTC?
0445.
Yeah, 0445. And what is the difference for standard time?
0800.
Plus minus
We need to plus it, sir.
plus it. So 0800 plus 445. You got
Yes.
1246.
12.
Yeah. Okay. Good.
Okay.
Right. Who else wishes to do number 7? Ziavi, will you try 7? Question number 3, part 7. Ziavi,
Yes.
huh? Can we attempt it? Number
No.
7? No? Why not?
I haven't done the whole section.
You haven't done. That's why let's do it together. Yeah?
Yeah.
That is why I'm asking you to do it. Okay, inclusive of flying, refueling time, the scheduled time from Rome to Hong Kong is 21 hours 40 minutes. Okay? If the flight must land at Hong Kong at 18:35 standard time, at what standard time must the flight leave Rome to arrive on schedule? Okay? So from 18:35, Zoe, you work backwards. Yes? So
Yeah.
put down 18:35. All right? Okay. From 18:35, what is the standard time to get? We'll work on UTC. Is the best. Yeah. Okay.
Yeah. You
Yeah.
convert
So
it
18:35. Then you how many hours for Hong Kong to get UTC?
you
How many hours is it in your almanac?
8 hours.
8 hours. So what do you do to that standard time to get UTC? Because Hong Kong is east,
Yeah. Plus.
UTC least. So you have to minus it.
No, plus it.
Why? UTC will be less than Hong Kong time, or will it be more?
Less. Sorry.
Less. So if it is less, you have to minus, no?
Yeah. Yeah.
Yeah. So 18:35 minus 8 hours. You get 10:35. Correct? So 10:35 now is your UTC for departure. Okay. Now 10:35. What is the flying time? 21 hours 40
21
minutes.
hours. Yeah.
Okay, add it. Add 21 hours 40 minutes. You get how much UTC? Remember, we are working backwards. Yeah. So when you add this, you add 21 hours, you have to go back in time. 21 hours 40 minutes. How much does that come, Joey? 10:35 UTC, go back 21 hours 40 minutes.
11:05.
No, just see that again. 10:35 minus 21:40. Just do it again. See how much you get. Ashraf, 10:35 minus 21:40. 21 hours, 40 minutes.
Uh,
12:55.
Very good.
12:55. Yeah.
That's it. Okay. Now 12:55 is UTC, remember. And this is 12:55 one day before. Yes, Javi?
Yes.
Okay. So it's one day before 12:55. Now we have to change this to standard time.
Yeah.
Yes. So what is the standard time for Rome? Rome will be plus or minus?
Plus.
Plus. Because
Minus.
it is, no, it is
Yeah,
plus.
you got it.
Because it is west. Okay. You have to add it to get, you have to add to UTC to get standard time. Correct. Javi, you have to,
Yeah.
we got
Isn't
12:55
it?
is UTC. Correct. Now you go back to find standard time. On the list, you'll find places west of UTC or west of Greenwich. It will say add that amount of time. Isn't it on top? It says add to UTC to get standard time. Where is that? List 3.
Yeah.
Yeah. So you have to add how much? Yeah, it says add to standard time to get UTC. Okay, I'll subtract from UTC to get standard time. Okay. So UTC was 12:55 and the standard time difference is how much? 1 hour? Yes, Yavi?
Yeah.
Yeah, okay.
You plus to it.
So you add and you'll get how much?
13:55.
13:55. Okay. Is it so confusing? Yeah, Yavi?
No.
No. Okay. All right. Someone to do number 9. Who wants to do this? If I ask you, nobody will want to do it. Yeah, Alicia? So can you explain if we have seconds when getting the arc time? We choose the minutes, either +1. When you get seconds, when you're getting arc time. Arc time seconds, you if it is you don't bother about seconds, Shakil. We have to work to the nearest minute. Okay, for all our problems. Okay, just disregard seconds, Shakil. Got it? Just whatever whole minutes, you take that into account. Don't bother about the seconds. Okay. Nina, will you try number 9?
Yes, sir.
Okay. An aircraft leaves Honolulu, Hawaii at 2300 standard time on the 10th of May. Okay. If the flight time to Sydney, New South Wales is 10 hours 20 minutes, what is the standard time of arrival at Sydney? You just have to go with the flow, right? 10th May, 2300 hours. Yeah, we are all working on standard time.
Yeah.
Okay.
I
So,
got first the departure.
yes.
Departure on standard time. I add the correction, which I got the UTC for departure.
How much? What is the correction?
09. The correction is 10 plus 10.
10 hours. Yeah, okay.
10 hours.
Hmm.
And then I got 11th May 0900.
Yeah.
And then I add the flight time, which is 10 hours 20 minutes.
Yes.
So the arrival of UTC is 11th May 1920.
Yeah, this is arrival where?
Arrival at Sydney.
Sydney. And now what do you have to do?
And then from the arrival UTC, I add the correction again for 10
So
hours.
This is UTC that we got, correct?
Yes.
That is
And then I got
1920.
the, yeah, and then I got the standard time at
Yeah.
10 hours.
Yeah.
So I got the arrival at Sydney for standard time is 12 on the 12th May 0520.
Yeah. Okay. Good. Good, Nina. All right. Hold to the last one.
Yes, sir, Abdul.
Yeah. Okay, Abdul. Do the last one.
So the departure is 2000. The standard
So
time.
we have to plan the arrival at Madrid. Okay.
Yes,
Departure is?
It's 2000 and standard time at 16 February.
On the 16th of February.
So that's a departure from New York. Then we
Okay.
need to do the standard time correction to get the UTC. So we get the UTC is 100 hours.
This is UTC.
Yes. So
This is standard time
UTC.
correction? Okay.
Yes, sir. So we get the UTC 100 hours at 17 February, the next day. And then
so what is UTC?
UTC is 100 hours, 0100.
010. Okay, all right.
And then the flight time is 7 hours 45 minutes.
Okay.
So we need to plus with the UTC.
Yeah.
So we're gonna get 845 minutes.
0845 UTC.
Yes.
On the
UTC.
17th.
17th February, and then we do the standard time correction for Madrid, which is need to add 100 hours.
Yes.
And we get
that is 1 hour.
09. Yeah. Sorry.
1 hour. 1 hour.
1 hours. So then we need to we get the arrival time at 9:45 hours.
On the 17th.
Yes.
Yeah.
And the 7th February.
Very good. Okay. Any other doubts, anyone on any of these problems to do with time, which you all did and which we revised some of them? This is Shakil. Sometimes I get 44 minutes, but when I check the answer, it uses 45 minutes instead. Like which one, Shakil? Give me an example. Why it's okay. If you have a doubt, let's clarify it. Oh, you got it already. Is it any different from what I told you, that we just stick to minutes, whatever it comes, and disregard the seconds? Yeah, Shakil, or have you seen anything different? Have you seen anyone, any of these answers taking seconds into consideration, Shakil? Because our datum is we're supposed to work to the nearest minute. Okay. Okay. Any doubts, anyone on any of these aspects? Okay. There is one thing which we didn't do last time, which I want to do. Okay. And this is about those odd cases, you know, where I told you that the land is very close to the international date line. And so for the purposes of calculation of time, the longitude is different. And we will do one such problem, which is there. Elisha, can you hear me? You seem to have come online. You're a bit hard to hear. Oh, okay. Abdullah, has the screen changed?
Yes, sir. Yes, sir. It's changed. Yes, sir. It's changed.
Change. Okay.
Change.
All right. Internet connection is unstable, whatever that may mean. Okay. I told you because of the location of the international date line and the islands that belong to various countries, which for administrative convenience, they want to keep on the same date. Obviously, if one part of the country is following the 10th of May, the other part of the country cannot be 11th of May. It's inconvenient. And so, for the purposes of time, they've changed the longitudes. Okay, this is one of them that we are going to see. Right? Yeah. So, if the local time in Tonga Islands, this is Tonga, yeah, okay, which is 170 west, is 8 o'clock 0800 on local mean time on the 10th of May. What is the standard time and standard date in the Tonga Islands? So the local time and local date is 10th of May. Okay, 0800 10th of May. Now let's see what is the standard time on the same Tonga Islands. And how do we do it? We change it to UTC and back again. So the local time on the 10th is 0800 LMT. Now the arc time based on this longitude is 11 hours and 20 minutes. For 170 west, it's 11 hours and 20 minutes. So you get UTC as 1920. Once you get UTC, and this is on the 10th, you have UTC time, you have to now apply the correction for standard time to be able to get the standard time of Tonga. So what is the standard time correction? Over here, you see it is 13 hours. So it is this correction that caters for the difference between is not too much. Okay, but you cater for 13 hours mainly to get it on the same time as Fiji. Okay, so when you add 13 hours, you get 8 hours 20 minutes standard time on the next day. Okay, local time 10th of May 8 o'clock. Standard time 11th of May 8:20. So whenever you meet someone in Tonga and he says you meet me on the 8th or so and so time, you'll have to ask him local time or standard time. Okay, so in most cases they act on it is on standard time. Okay, nobody follows local time in these areas. Is this understood? You see that it is the 10th of May and it is 8 o'clock local time. But the standard time for the same date and time is actually 11th of May 8:20. That is because of the corrections that we have made in the longitude for the sake for administrative convenience. Is this clear, everyone? Any doubts on this?
Yes, sir.
Yeah. What are the rest? Everyone
Yes,
clear on
sir.
this? Okay. Okay. All right. Let's go on to sunrise and sunset. Till now, for all purposes of time, we were taking only longitude in account. Okay. But when we talk about sunrise, sunset, okay, and twilight time, etc., we will be talking in terms of latitude, because latitude is the one that affects our sunrise and sunset, okay, and is the declination of the sun that affects the length of day and night. And the declination of the sun depends on the time of the year. Okay, now let's start with this. On an imaginary earth, if there is no tilt, no atmosphere, the sun will rise at 6 o'clock and it will set at 1800 hours. Okay, but because there's no tilt, there won't be any seasons. Okay, the Earth's tilt is the one that gives us the season. If there's no declination, there's no season, right? So the effect varies with latitude, and the declination of the sun varies with the calendar. So in case there was no tilt, no nothing, then you will have equal periods of day and night, etc., no seasons. Okay, life will be most uninteresting. But because of the tilt and the declination of the sun, you get the varying times of light and darkness. So let's tilt the sun. Okay. Now this is on the 21st of June. Right? There on the 21st of June, over which tropic is the sun? There.
Yes, sir.
On which tropic, over which tropic is the sun on the 21st of June? You have to keep your mind on your studies, huh? Because it's a very simple thing. Yeah. Okay.
On the north, sir. Tropic of Capricorn.
No, it's not Capricorn. On the north is correct. It is over the northern tropic and is the tropic of Cancer. Okay,
okay, sir.
There.
Okay.
Yeah, the sun will be over the northern tropic. That's correct. But the name of the tropic on the northern 23.5 degrees north is Tropic of Cancer. So
okay,
21st of June, yeah, it will be over the. Now let's see the period of. Now I told you that the periods of daylight and darkness is depending on the declination of the sun. So the declination of the sun is the angle that the sun makes with the equator. Right? Over here, it is over the northern tropic, Tropic of Cancer we just discussed. Okay? So let's see this observer R. This at this point R. Right? If you'll notice the number of hours of now this is in the summer in the northern tropics. So if the observer's here, he has very little light and mostly daylight. You see. Darkness, daylight. That means sunrise is before 6 o'clock and sunset is after 1800 hours. That is why you have such a long day. This happens in summer. Okay? So a short night and a long day. Now let's see the observer at S. The observer at S is in the southern latitude. Okay, it is winter for the southern hemisphere. Australia, New Zealand and all, they have, in June, they have their winter. So if you have an observer here, you'll notice he has a long night and a very short day. This is their winter, winter in the southern hemisphere. That means the sun rises much after 6 o'clock in the morning and it sets well before 1800 hours in the evening. And that is why he has such a short day, daylight, a long night. Okay, clear anyone? Any doubts? All right. But you see the observer at the equator. Equal night, equal day. Okay, at the equator, most times it is equal night and equal day. Okay. Now the LMT of sunrise and sunset can be, of course, extracted from the air almanac. And in this case, you have to refer to the latitudes. Okay, so all sunrise, sunset, twilight, etc. is on LMT, local time. So should you wish to broadcast it or put it in the form of a NOTAM, etc., you'll have to change it to standard time to put it. Is this clear? All right. Now let's see. This is in the summer months, our summer. Let's see our winter, what happens. Oh. Okay. In winter, I don't think I have a slide. The opposite happens. Yeah. Okay. The sun is on the other side. Right. So this part becomes lit up. And it is the summer for the southern hemisphere. Because it will be tilted this way. The sun will be here. And it will be over the Tropic of Capricorn. When the sun is here, it is over the Tropic of Capricorn. Okay, and all this will be opposite, right? For an observer in the northern hemisphere, the nights will be longer, the days will be shorter. In the southern hemisphere, the days will be longer and the nights will be shorter because the sun will be on the other side. But on the equator, it will be equal periods of light and day. Okay, the opposite happens when it is over the Tropic of Capricorn. This part about sunrise, sunset, and why it affects at various parts of the year, is this clear?
Yes.
How this, yeah, everyone clear?
Yes, sir.
Hours of daylight and darkness, the declination of the sun, okay. Now we'll study something called twilight. Okay. Rajesh, what do you understand by twilight? Rajesh. Can you hear me, Rajesh? Okay, Hazik.
It's when the sun is below the horizon, but you still see the light coming from it.
Yeah. Okay. When is there twilight, Hazik? In the morning or in the evening?
Both.
Both. Okay.
Before sunrise and after sunset.
Yes. Absolutely right. Yeah, Rajesh. But why aren't you responding when I call you, Rajesh?
My line is quite slow, sir.
Somewhere else?
My line is quite
okay.
slow.
Okay. All right.
Yeah.
All right. So it is twilight happens during both during day and during evening. Okay, before sunrise and after sunset. Twilight is a time when you can actually do most of the activity that you will do during the daylight. Okay, so there are various definitions of twilight depending on what twilight. There's something called the civil twilight and twilight which is outside the civil twilight. Okay, so civil twilight is the time, twilight we know is the time between after sunset and before sunrise. And it is the time when you can do most of the work that you can do most of the work that you would do during the day. Civil twilight is the twilight time when you can do all the activity that you can do during the day, you can do during the civil twilight hours. That is the definition of civil twilight. Okay. Yeah. So before sunrise and after sunset, when there's a period when it remains light, and these periods are called twilight. So I told you there's something called civil twilight Okay. Yeah. And this is, you need to know that there are different types of horizon. All right. We will then correlate it with the sun. Now, this is called the sensible horizon, where the horizon is a tangent to the globe, where it just touches the earth. That is called the sensible horizon. Why sensible horizon? Because if you put a sensor, if you put a spirit level over here, it will read level. The bubble will come to the center. That is why it is called sensible horizon, to say that if you put a sensor here, it will show completely horizontal. But this horizon does not mean that it is sunset. Yeah, because what happens is there is a refraction of light. So actually, it is the visible horizon when your sunset commences. Your sunset commences at the visible horizon. When we say sunset, we are talking about the top end of the sun coming in line with the horizon. Okay, the sensible horizon, what do you call it? The visual horizon is 34 minutes below the sensible horizon. Okay, 34 minutes by way of angle, not time. This is 34 minutes below the sensible horizon. But when the sun, the tip of the top tip of the sun is over here, the center of the sun is still 16 minutes away. Okay, it is still 16 minutes away. And so from the sensible horizon till the sun, the middle of the sun goes past the point, it is a total of 50 minutes. 34 minutes from the sensible horizon to the visual horizon, and 16 minutes from the visual horizon till the middle of the sun. So this 50 minutes of angle converts to 3 minutes of time. Is this clear? So the center of the sun is approximately 50 minutes of the arc below the sensible horizon, and this is equal to 3 minutes. That is why at the equator, sunrise to sunset, sunrise is at 6 o'clock, sunsets at 1800 hours, but you have daylight 6 minutes before and 6 minutes after. 6 minutes before sunrise, 3 minutes before sunrise, and 3 minutes after sunset. So when we're talking about 12 hours from sunrise to sunset at the equator, it is actually 12 hours and 6 minutes, because 3 minutes before sunrise and 3 minutes after sunset. Is this part clear? If at the equator I am saying the sun rises at 12 o'clock, sunset 1800 hours, actually your period of light is 12 hours and 6 minutes, because you get 3 minutes before sunrise and 3 minutes after sunset, because of the reason we just discussed. Because of the 50 minutes of angular time you have for the sun between the sensible horizon and the bottom of the sun. Any doubts? Okay. First is, I told you the definition of twilight is where you can do all the activities during twilight that you can do during the sun, during sunlight hours. Okay, twilight is civil twilight is a time where all the activities that you do during the day can be done during twilight hours, civil twilight hours. That means takeoff, landing, everything is counted as day. Okay, So, and this happens from sunset or till when the sun is 6 degrees below the horizon. Sunset till 6 degrees below the horizon, sensible horizon, is civil twilight. Okay, from the time that the top of the sun goes down below the horizon till it goes 6 degrees below the horizon, it is civil twilight. Then there is the next phase is something called nautical twilight. Nautical twilight is when the sun is between 6 degrees and 12 degrees below the sensible horizon. During nautical twilight, you can see outlines of things. Okay, it is not as good as civil twilight, but you can see outlines of objects and the bright stars are visible in the sky. That is the definition of nautical twilight. One is that it is between 6 and 12 degrees between the sensible horizon. The sun is between 6 and 12 degrees below the sensible horizon. And the second is that you can see outlines of objects and you can see bright stars in the sky. That is the nautical twilight. Then what is? There's something called astronomical twilight. That is when the sun is between 12 and 18 degrees below the sensible horizon. This is actually darkness. You can't see anything. It is as if it is dark. Okay? So, astronomical twilight is between 12 degrees and 18 degrees of the sun below the sensible horizon. Civil twilight, 6 degrees position of the sun, 6 degrees below the sensible horizon. 6 to 12 degrees below the sensible horizon is nautical twilight, and 12 to 18 degrees below the sensible horizon is astronomical twilight. Is this clear? Any doubts, anyone? Okay.
Hello?
Yeah. Yes?
What's the significance in knowing the difference between astronomical, nautical, and also civil twilight, sir?
You have to know as an aviator, okay? You are obviously your knowledge should be more than plain geography from school, no? Yeah, Ashraf? That is all. You must know. You must know what is civil twilight. Civil twilight is material to you because it amounts to your making use of civil twilight. You'll be landing, taking off, etc., carrying out all operations during civil twilight. But the others is for you to understand and recognize. If a literature refers to nautical twilight or astronomical twilight, you must know what is meant by that. Yeah, clear?
Yes, understand,
Okay.
sir. But why do we need to know the difference? I mean, what's the significance between nautical and astronomical, for example?
Between nautical and astronomical twilight. Knowledge as an aviator. That's it. And
just for general knowledge, yeah?
Yeah, from our immediate viewpoint, it will come, you might be asked in the exam because it's part of our syllabus. It may be a theory question. Yeah, Ashraf.
Okay, sir.
That is our immediate requirement. Okay. Now, the twilight time, the minimum twilight time is 21 minutes. Okay. Between the sensible horizon and 6 degrees of the sun going below the sensible horizon, it will not be less than 21 degrees. If at all, it will be more than 21 degrees. And where will it be more than 21 degrees? When depending on the latitude that we are at. if we are on the higher southern or higher northern latitudes, okay, because we will see, has your slide changed? Is it showing twilight too, Abdul? Abdul, is it showing twilight too?
Yes, sir.
Okay. So this is when the sun is directly above us. During the time there's an observer in the higher northern latitude or higher southern latitude, depending on the time of the year, the sun will travel like this way, and this way. You just see, yeah. There it is. Okay, this time for the sun to travel between here and here is 21 minutes. So obviously between here and here, it is more than 21 minutes. The same will be for this when the sun comes in the higher southern latitudes. Yeah, the same thing. It will be more than 21 minutes. Yeah. Okay, this is at least 21 minutes. Is more than 20. Is this part understood? This is the twilight time. Okay. Abdul.
Yes, sir.
Radhika, put on that switch. This thing is not on. I want this ATPL YouTube, no? Put on 76 slide now, that CPT number 76, just because when I put it on, you don't get the voice. YouTube ATPL 76.
You mean from YouTube?
Say again?
You mean from YouTube?
YouTube, yeah. Because my CPT you can't see. And then you share it with me. What I'm going to show you now, once he launches that CPT, is that during winters, okay, depending on whether you're in the southern or northern hemisphere, the sun never rises in winter. Okay, it will show you the position of the sun, the way it rises. It comes to the sensible horizon and goes down again. Yeah. Put 70s. Go to the next one, 77, 78, put 78. Yeah. Yes, put this on.
This one?
Yeah.
However, this time we have 60 knots headwind.
Oh, there's something wrong.
Now, the onward ground speed.
No, Abdul.
Yeah.
I think it's 76. Sorry, this is not the one. Go to 76. Oh, we'll run out of time quickly.
This one?
Yeah, 76.
We showed in an earlier lesson that at latitudes above the Arctic and Antarctic circles, it was possible to have continuous daylight or continuous darkness at certain times of the year. These symbols are used in the Air Almanac to indicate these phenomena. Let's look at what they mean. The first indicates that the sun remains continuously above the horizon. This occurs at a high latitude summer. The path of the sun is like this. It comes down and up in the usual way, but at its lowest point, which is at midnight, it is still above the horizon. There is no sunset or sunrise. The second symbol means that the sun remains continuously below the horizon. This occurs at a high latitude winter. The sun comes up and down in the usual way, but at its highest point, which is at midday, it is still below the horizon. There is no sunrise or sunset. And the final symbol means that in the period between sunset and sunrise, the sun is never less than 6 degrees below the sensible horizon. This occurs during a high latitude summer. The sun sets, but at its lowest point, at midnight, it has not reached 6 degrees below the horizon. We still get a sunset and sunrise, but twilight lasts all night. The sunrise, sunset and twilight tables are based on an observer at mean sea level on flat ground or looking out to sea. An increase in altitude will increase the sensible horizon, thus making sunset later and sunrise earlier. It also makes twilight shorter. However, you will not be required to calculate any of this. A further variable to the length of twilight is caused by volcanic activity. In an area of volcanic eruption, the length of twilight will be increased due to the increased scattering of the sun's rays. In practice, you are unlikely to be flying in such conditions. Finally, you should note that the beginning and end of civil twilight are the practical basis for working out when it gets too dark to see safely and can be used worldwide. However, within the UK, the Air Navigation Order states that for legal purposes, such as logbook entries, night flying takes place 30 minutes after sunset until 30 minutes before sunrise. Let's summarize this lesson. We showed that the times of sunrise and sunset are determined by latitude and the sun's declination. At the defined time of sunrise or sunset, the sun is a total of 50 minutes below the sensible horizon. This is the figure that is used in the Air Almanac tables. It always makes at least 3 minutes difference at both ends of the day. We saw how to look up the times of sunrise in the Air Almanac. But these are local mean times. To make them useful to us, we have to convert to UTC, and then possibly to standard time if required. However, before sunrise and after sunset, there is a period when it is still light enough for everyday tasks, including landing and taking off from an airfield without lighting. This period is known as civil twilight. There are also periods of nautical twilight and astronomical twilight, but these need not concern us as aviators. The local mean times of the beginning of morning civil twilight and the end of evening civil twilight are given in the Air Almanac in the same format as the sunrise and sunset tables. Again, they need to be converted to UTC to be useful. To find the duration of twilight, compare its time with that of sunrise or sunset as appropriate. Twilight can never be shorter than 21 minutes, which occurs at the equator at an equinox. Remember the significance of the 3 symbols used in the Air Almanac to cover high latitude special cases. An increase in altitude will increase the sensible horizon, thus making sunset later and sunrise earlier. It also makes twilight shorter. Finally, within the UK, the Air Navigation Order states that for legal purposes, such as logbook entries, night flying takes place 30 minutes after sunset, until 30 minutes before sunrise. This concludes all of the lessons on time.
Okay, thank you, Abdul.
Okay.
Any questions, anyone? Okay, the small portion that we will cover, and we'll do some problems connected with sunrise, sunset, and twilight in our next class. Yeah, okay. Any doubts, anyone, on what we've covered today? On sunrise, sunset, twilight, and those three symbols that appear on the top of your page in the almanac. Okay, when it's dark throughout, when there's no sunrise, and when it's twilight throughout. Okay. Any doubts? Oh, wow. Gilbert, you could hear throughout. There's no problem. Gilbert, Shakil, and Elisha. Okay. The remaining, no problem.
No problem, sir.
Okay. Who's on? Let's see who's online. Suren, are you there? Where's Suren? Okay, Suren didn't attend today. Okay. Aizam? How many total? 17. Okay. Hyman?
Yes, sir. I'm here.
Okay. Rajesh, you're there?
Yes, sir.
And Gilbert? Gilbert cannot. Yeah, okay. All right, Gilbert. Azik?
Yes, sir.
Bye, Azik. Bye, Nina.
Bye, sir.
Bye, Ziavi.
Bye, sir.
Bye, Dea.
Goodbye, sir. Thank you, sir.
Yeah, thank you. And Alicia? See you, Alicia. Bye-bye. I hope I'll be able to hear you sometime. Okay. Gulen was not there. Lynn? Bye, Lynn.
So,
Bye, Ashraf.
Bye, sir. Thank you.
Bye. Yeah, thank you. Bye, Ikhwan.
Bye, sir. Thank you, sir.
Thank you. Bye, Hakimi.
Thank you, sir. Bye.
Yeah, bye, Julie.
Bye, sir.
Bye. Avzai didn't come on today, did he? Avzai? Okay, Avzai not. Bye, Shakil.